Before we start, a word of warning. This video is going to get emotional, because today we're drawing something that can make us laugh and make us cry. No, not the Lion King, but the facial nerve. The facial nerve is the seventh of the cranial nerves, those small paired nerves that leave the brain and brainstem directly. To draw it, I'll be adding its nerve fibres to this illustration here. We'll start by drawing the fibres that leave the brainstem and travel through the skull, what's known as the intracranial portion. The nerve then finishes by exiting the skull and giving branches to the face and neck, and this is the extracranial portion. The facial nerve starts as two routes leaving the pons. There's a motor route that contains motor fibres, and a sensory route, also called the nervus intermedius, that contains sensory fibres. Now this route also contains parasympathetic and special sensory fibres, but to stop our illustration getting too cluttered, I'll be drawing all three as a single line. Both routes leave the brain and enter the skull via the internal acoustic meatus. The eighth cranial or vestibulocochlear nerve also entered the skull through this meatus, and this relationship can become important when looking at lesions of the facial nerve. From here the roots fuse together to form a single facial nerve, before entering a small tunnel that runs through the temporal bone and is known as the facial canal. Now the shape of the canal means the nerve makes a number of sharp turns. These bends are known as the genua, after the Latin word for knee. At the first bend we'll find the cell bodies of the sensory nerves. Remember, a collection of cell bodies in the peripheral nervous system is called a ganglion, and because these cell bodies are found at a genu, we'll call this structure the geniculate ganglion. The nerve also gives off three intracranial branches as it runs through the canal. The first of these, the greater petrosal, delivers parasympathetic innervation to the lacrimal gland. This allows the gland to secrete fluid that lubricates and protects the surface of the eye. It's also the gland that goes into overdrive when you watch the end of Marley and Me. Next we have the nerve to stapedius. Stapedius is a tiny muscle that connects to the stapes, one of the three bones that transmit vibrations from the tympanic membrane to the cochlea. When we're exposed to loud sounds, stapedius contracts, holding the stapes in place. This limits movement of the bone and reduces the transmission of vibrations to the inner ear. Finally, the chorda tympani innervates structures in and around the mouth. So there are parasympathetic fibres that pass to the sublingual and submandibular salivary glands. It also contains special sensory fibres that provide taste to the anterior 2/3 of the tongue. From here the facial nerve leaves the temporal bone through a hole or foramen between the styloid and mastoid processes. To name it, we just smush those words together, giving us the stylomastoid foramen. At this point the nerve becomes extracranial and pretty much only contains motor fibres. However, a small number of sensory fibres travel out to supply skin around the concha of the ear. The rest of the nerve continues anteriorly towards the face. On its way it gives off three small motor branches to muscles around the ear, the posterior belly of digastric, and the stylohyoid muscle. Now these branches aren't super important, but I've mentioned them because they could always come up in a tricky exam question. The facial nerve then travels up and through the parotid, that large salivary gland in front of the ear. Now, despite travelling through the gland, the facial nerve doesn't innervate it. Instead, it divides into 5 motor branches that innervate the muscles of facial expression. First, a superior division, the temporal branch, controls muscles in the forehead, allowing us to lift our eyebrows up. A zygomatic branch innervates orbicularis oculi, and this is the muscle we use to tightly shut our eyes. The buccal branch heads to muscles above and around the mouth. These are used for smiling or launching a career as an influencer. Next, the mandibular branch innervates muscles below the mouth, allowing us to frown. And then finally a cervical branch passes to platysma, that thin muscle covering the neck. Now, while I try not to use mnemonics too much, I definitely find them a helpful way to remember these branches. Personally, I go for 10 zebra have bit my cat, but feel free to use whichever one works for you. Lesions of the facial nerve can present with a variety of symptoms, depending on where the damage occurs. As with any peripheral nerve, the symptoms of nerve damage will always be distal to the location of the damage. So, damage at the internal acoustic meatus would affect all of these branches. This might be caused by an acoustic neuroma, a tumour of the vestibulocochlear nerve compressing the facial nerve. In this case, loss of innervation to the lacrimal gland would result in dry eye. Without the ability to limit vibration of the stapes, they'd suffer from hyperacusis, or sensitivity to sound. Loss of the chorda tympani would reduce saliva production, as well as taste to the front of the tongue. But perhaps the most obvious and most concerning symptom will come from the loss of motor innervation to the face. The patient will be left with facial paralysis, or palsy, to one side of their face. A more distal injury will have less widespread symptoms. For example, a lesion here could still result in dry mouth, loss of taste, and facial palsy. But since the lacrimal gland and stapedius don't lose their nerve supply, the patient shouldn't have dry eye or hyperacusis. Damage to the extracranial portion typically only presents with facial paralysis. For example, an issue with the parotid, such as cancer or parotitis, can compress the nerve and cause facial palsy. However, sometimes facial palsy have no apparent cause, and in these cases, the condition is known as Bell's palsy. Of course, lesions in the facial nerve aren't the only cause of facial palsy. For example, a common symptom of a stroke is unilateral facial paralysis. So, how can you tell these conditions apart? Well, to understand that, we need to look more closely at the motor fibres of the facial nerve. So in this illustration, we've got a cross-section through the brain and the brainstem. The motor nerves that travelled out to the face start here, as a cluster of cell bodies in the pons. Now we've seen that a group of cell bodies in the peripheral nervous system is known as a ganglion, but when we find a cluster in the central nervous system, we call it a nucleus. This facial nucleus is split into two regions. Fibres from the dorsal region innervate the muscles of the upper face, and the ventral region sends fibres to the lower face. These fibres running from the pons to the face are known as lower motor neurons, and that's because we have upper motor neurons that pass from the cerebral cortex and synapse with those lower neurons at the pons. These upper fibres mainly originate in the motor cortex of the contralateral hemisphere, so the left side of the brain primarily controls the right side of the face. However, a small number of upper motor neurons originate in the ipsilateral cortex. These fibres head to the dorsal region of the nucleus and help to control muscles in the upper face. So why is it helpful to know this? Well, knowing these pathways allows you to differentiate between an upper neuron issue, such as a stroke, and a lower neuron issue, such as Bell's palsy. Damage to the lower motor neurons will cut off all nerve supply to that side of the face, so the patient will have complete facial palsy. The corner of the mouth drops, the nasolabial fold disappears, the eyes can't close, and the forehead won't wrinkle. These symptoms become particularly obvious when they try to smile. A stroke will affect the upper motor neurons and cause some slightly different symptoms. Firstly, the symptoms will appear on the contralateral side to the injury. Secondly, although most of the innervation to one side have been lost, those ipsilateral fibres are still functional. This means muscles in the upper face still receive innervation, and the patient should be able to wrinkle their brow on the affected side. Finally, the motor cortex isn't the only region of the brain sending upper motor neurons to the facial nucleus. We also have some fibres passing from the limbic system. Now, the fibres from the cortex control conscious movements and facial expressions, but the limbic system is responsible for unconscious behaviours and responses. So a patient that suffered a stroke may suffer from facial palsy, but still be able to blink or smile in response to a joke. If the limbic system is damaged, we can also see a reduction in those unconscious facial movements, So for example, a patient with Parkinson's, such as my dad, say hi Dad,
Hi, Dad.
will have a reduction in those emotional and behavioural responses. This explains the lack of facial tone, the reduction in blinking, and why even my best anatomy jokes can barely raise a smile. So that's an overview of the cause and potential damage to the facial nerve. If you have any questions, please just get in touch. But otherwise, thank you for watching, take care, and I'll hopefully see you again soon.